A linear equation is an algebraic equation in which each term is either a constant or the product of constant and the first power of a single variable. However, different variables may occur in different terms. A simple example of a linear equation with only one variable, x, may be written in the form x plus b equals 0, where a and b are constants and a does not equal 0. The constants may be numbers, parameters, or even nonlinear functions of parameters, and the distinction between variables and parameters may depend on the problem. The study of linear algebra includes the topics of vector algebra, matrix algebra, and the theory of vector spaces. Linear algebra originated as the study of linear equations, including the solution of simultaneous linear equations. An equation is linear if no variable in it is multiplied by itself or any other variable. They are used in dealing with the coefficients of simultaneous equations. Using vector and matrix notation, a system of linear equations can be written, in the form of a single equation, as a matrix times a vector. Linear algebra is also the basis of a process called linear programming, widely used in business to solve a variety of problems that often contain a very large number of variables. Linear equation used in business management. Depreciation of a car. New price equals $50000. Loses equals $1,500/year. Let X equals number of years since purchase. Let Y equals value of a car in dollar. Y equals 50000/1500x. What is the value of car after 10 years? Y equals 50,000 1,510. When is the value of car equals $20,000? 20000 equals 50000/1500x. 3000 equals...
It had 27,000 miles on it. And I've owned it for a while now, and every year I drive it about 12,000 more miles. And so what we end up with is a linear equation to represent the situation that looks like y equals 12,000 x plus 27,000, because I drive it 12,000 more miles every year, so that's how much the pattern moves by, and the pattern began at 27,000 miles when I first bought the car. So after year 1, it had 39,000. Then after year 2, it had 51,000. Then after year 3, it had 63,000, and so on and so on. Drawing a graph of this linear equation can help us make a lot of predictions about what this pattern is going to do in the future. And it can also give us a better sense of the pattern that might not be quite so easy to see just from looking at the numbers. When I want to graph a linear equation, I use the y-intercept, the b value, as my beginning value on my graph. And before I had owned the car for a single day, it already had 27,000 miles on it because I got it used. Then, after 1 year, I was driving it along, and after year 1, I was up to 39,000 miles. Then I kept driving it. After year 2, I was up to 51,000 miles. So every time I go over 1 year, I go up 12,000 miles.
Cost. Revenue. Profit. Cake and seller. Cost in dollar is CX equals 1.5x plus 756. 1.5x equals variable cost $1.50 each cake to make. 756 is fixed cost. Revenue, Rx equals 15x. Cost, Cx equals 1.5x plus 756. Profit, Px equals Rxcx. Profit, Px equals Rxcx. Px equals 15x 1.5x plus 756. px equals 13.5x, 756. Break-even point. Total cost equals total revenue. Cx equals Rx. Total profit at break-even point is 0. How many cakes need to make to break-even point? Px equals 0. 13.5x, 756 equals 0. 13.5x equals 756. X equals 56. Cost. Revenue. Profit. Cake and seller. Cost in dollar is Cx equals 1.5x plus 756. 1.5x equals variable cost $1.50 each cake to make. 756 is fixed cost. Revenue, Rx equals 15x. Cost, Cx equals 1.5x plus 756. Profit, Px equals Rx Cx. Profit, Px